Hello everyone. In this tutorial lab, we are going to take a look how to handle exceptions in a PLINQ query. Here is our material. In this material, we have two projects. One is web service and another one is web client. The web service actually is a RESTful API, and the web client is just a console application, and we will call the REST API from the console application. First, let's take a look at the web service. And open the folder, run cmd, type .NET restore. Okay, and right-click the blank area of the folder and click Open with Code. Here is our web service code. So this is a RESTful API controller. And in the controller, we have a dictionary. For the dictionary, we use the continent name as the key and the population of this continent as the value. As we see, we have 7 continents here. And we expose the data with the HTTP GET method. If you provide the continent name to the HTTP GET method, the HTTP GET method will look up for the continent name in the dictionary. If the lookup dictionary had the record of this continent, and it will return the population of this continent. If the lookup dictionary doesn't contain the continent name, and it just return a not found. And we know the status code of not found is 404. 404. And the OK status code is 200. Okay, now let's run the application. Close the web browser, and I have the Postman installed. Let's create a new access. HTTP localhost 5000 API populations, and give a name equals to Asia, and send. We got the population, and we see the status code is 200. Okay. Now let's try a wrong continent name. Let's see, Utopia. And we'll see we didn't get any population, and we see the status code is 404. Okay, the web API works. Now we close the Postman. Let's keep the web API running in the background, and we open the web client folder. Do the same thing, cmd .NET restore, and open with code. Here we have a static method. If you give a continent name to the get population method, and first we'll construct a URL and to access our RESTful API, and this URL is just the same URL we used in the Postman. And we create an instance of the HTTP client class, and we use this HTTP client object to launch a HTTP GET access to the URL and try to get the result from the HTTP request. After we get the result, we compare the status code with HTTP status code .ok, which is 200, to see if we get the population. If the status code is 200 OK, that means we get the population and we return the population. If the status code is not 200, then there's something wrong. And we throw an exception, and the message of this exception is this continent does not exist. Actually, we should add the dollars here. Okay, let's go back to the main method. In the main method, we have a continent name string array. And then there is a standard LINQ query. And in this LINQ query, we use the select operator to generate a collection of objects. And each object has two properties. The first property called continent. The value is the continent name. And the second property called population. And we get the population by calling the getPopulation method. And we know this method will call the web API and try to get the population for the continent. And after we get the collection of new objects, and we iterate the collection and to show the continent name and its population. Now let's press Ctrl F5 to run the web client. And we see there are 7 items here. Now let's go back to the web service. Stop the web service, and we create some latency to simulate the internet latency. Task.delay, and we're 2000. That means 2 seconds. Wait. And press F5. Run the application and switch back to the web client and press Ctrl F5. This time we see we'll print the item one by one. And we see there is a 2 seconds interval between the printing of 2 objects because we made some latency in the web service application. Good. Now let's take a look how to handle exceptions for the standard LINQ. We add 2 continents, Atlantis and Utopia. As we know, there aren't these 2 continents. Now let's press Ctrl F5. Okay, we see there is an unhandled exception because when we call the getPopulation method with Atlantis, and the RESTful Web API will return a 404 status code. And then once we get a non-200 code, and we will throw an exception. Because we didn't handle this exception, and this exception just crashed our application. So that's why we need to handle the exception for the applications. Okay, let's handle the exception. Add try catch, paste the code and press Shift Alt F to format the code. And after we catch the exception, we just show the message of the exception instead of let the exception crash our application. And now we press Ctrl F5. Okay, now we see Atlantis does not exist, and this is the message of the exception. And the exception didn't crash our application because we caught this exception. We handled this exception. After we handled this exception, the application is finished. And you may notice, at the first time we got an exception, the exception handling just stopped the application. So we even don't have a chance to call the API with Utopia. So let's see here, after we call the web API with Atlantis and get a exception, and the application stopped, and there is no exception generated by calling the web API with Utopia. So this is how we handle the exception for standard LINQ query. Now let's take a look how to handle exceptions for PLINQ queries. Let's remove these two continents first. As we see, when we access a web API with a standard LINQ, it's very inefficient because each time we have to wait for the latency. And so if we switch to PLINQ as parallel, and then we can generate multiple tasks or multiple threads and let this multiple thread to access the web API at the same time, so we can get the HTTP result faster. If I press Ctrl F5, see, this time we wait 2 seconds and get all the return values back. That's because the as parallel operator just converted the standard LINQ query to a parallel LINQ query. And the parallel LINQ query will create multiple tasks, and each task will take one continent name and to call the web API. And after all of the tasks get the return value, and they aggregate them together and to generate the final result. And that's why we see the final result show on the screen together. Okay, now let's see how to handle exceptions for the PLINQ. We add the two continent stack. Atlantis and Utopia. Okay, let's press Ctrl F5. And we saw a very weird exception message. The message is one or more errors occurred, and one or more errors occurred, and Atlantis does not exist, and blah blah, and Utopia does not exist. What happened there? Because when we use the PLINQ, the parallel LINQ, the exception here is not just a common exception here, it should be a called aggregate exception, called EX. And in the aggregate exception, it has some inner exceptions. So what we should do is do a for each, let's see, inner exception in the EX dot inner exceptions, and we print the inner exception dot message. And now we press Ctrl F5. Okay, now we see there are two exception messages. One is Atlantis does not exist. Another one is Utopia does not exist. Now let's explain why this time we just get two exception messages. As we know, the PLINQ will generate multiple tasks, or say multiple threads, to access the RESTful Web API. And after all tasks finished, the PLINQ will aggregate all the results of each task together to generate the final result of the PLINQ query. That means if any task is failed, the whole PLINQ query will be failed, because when it do the aggregation, it cannot get the complete final result. That's very different from the standard LINQ. And we see even there is exceptions, and the standard LINQ still can get some result. But for the parallel LINQ, if there are exceptions, and we cannot get any result. So this is the first. Second, because the PLINQ query is using multiple tasks to access the web API, Atlantis and Utopia could be assigned to different tasks. If the task which is accessing the web API with Atlantis get an exception, it will notify the PLINQ query to cancel all other tasks. But the task for Utopia is already started, so it cannot stopped. That means eventually that task will get an exception too. So that's why we may get multiple exceptions in PLINQ. This is also different from the standard LINQ. As we see in the standard LINQ, once there is an exception, and the standard LINQ will stop immediately. We don't have chance to get another exception in a standard LINQ query. So this is how we handle exceptions for PLINQ query.